Hello everyone, welcome back to my channel. So again in this video I'm going to solve, I'll take any one problem from this question paper and let us solve that problem. And you should know the procedure to solve the problem on source transformation. Okay, so let us see 18EE32 electric circuit analysis question paper. I hope the subject name is electric circuit analysis. So from here I'm solving a problem number 2C. Reduce the network, that is a given network, you can see here, to a form with only one current source terminals using source transformation. The given A and B terminal, you should reduce this network with the help of source transformation to get a single current source. So single current source is nothing but always it is a practical current source. So without wasting time, let's go to the problem. You can see, and I already explained how to do a voltage transformation into a current and current into a voltage. So you can consider this problem now. So you want to reduce this network into current source. That's nothing but, so in between A and B, you should get one resistor and one current source. So in this form, you have to reduce this network. R and I value. I don't know the direction of current, either A to B or B to A. Okay, so now what can able to do? So can do here, okay, you cannot add the voltage sources when they are connected in parallel, but you can add the current sources if they are connected in parallel. But you cannot add the current sources if they are connected in series. I'm talking about practical current sources. If you are connecting in series, you cannot add that practical current sources, but you can add practical voltage sources if they are connected in series. Okay, so with that logic or with that concept, you need to know here the voltage sources which are connected in parallel so that you cannot add. So you need to convert these voltage sources into current source. Similarly, here one current source and one voltage source in parallel. So again, you need to convert this voltage source into current source. So totally three voltage sources are there. You need to convert all these three voltage sources into current source. So let us solve the problem now without wasting time. So I will take this problem. So first what I will do, step one, okay, I will transform 2 ohm 4 voltage source into current source, I source. So the circuit which looks like this, sorry. So from A, you have here one current source. I'll keep as it is, that is 2 ohm, and we'll be having a voltage source. Now I will do transformation, this voltage source into current source. So it becomes 1 2 ohm is parallel to a current source, and the direction of this current source you can see here, plus minus you have. So tail end indicates negative, R end indicates positive. So obviously current direction is from B to A. So that the direction of current is B to A. This I is given by V divided by R, whereas voltage is 4 and resistance is 2. You can get 2 ampere of current along with the 2 ohm of resistor. Here one more current source is there, that is B to A again. The direction is, and the value of this is 1 ampere, and this combination is series with these two voltage sources, that is 3 ohm 6 volts minus and plus. Similarly, one more 3 ohm 3 volts, one sorry, one more 3 volts, that is plus minus 3 volts, is in series with 1 ohm resistor, and these combinations are parallel to B. So it is 1 ohm, and again this is 6 volts, 6 volts, and this is 3 ohm. So now we can observe here two current sources are in parallel, so you can add or subtract the current, but see the direction of current now. 2 ampere current direction is from B to A. Sorry. Yes, B to A. And 1 ampere current direction is also B to A. Same direction currents are added together. If the current direction are in opposite, then you need to do what? You need to take difference of the currents. At the same time, you need to write the direction of current, the source where it is having highest magnitude. So here 2 ampere and 1 ampere are in parallel and the same direction. You need to add the current sources. You get only one current source from A, that is nothing but 1 plus 2. Here I will write the direction is from B to A because same direction will be having, so that current value is I equals to 1 plus 2. That is nothing but 3 amperes. The direction is from B to A. And again here R equivalent 1 I will consider. So this R equivalent 1, I will write it here itself. R equivalent 1, that is nothing but 2 is parallel to 2, we'll get 1 ohm. So that 1 ohm is parallel to 3 ampere current source, 1 ohm. So now I will convert that two voltage sources into current source directly. You can see here 3 ohm will come here and you'll get one current source here. Similarly, 1 ohm that will come here and there is one current source here. Like this, it is connected to B. So you need to know the direction of this current. So 6 volt minus to plus, so that is nothing but A to B. And the value of current I is given by V divided by R, that is nothing but 6 by 3, obviously 2 amperes. Similarly, you can observe one more current source, 3 volts, again B to A, minus to plus, B to A. So that is nothing but this I is given by V divided by R, whereas V is 3, R is 1, you can get 3 by 1 is nothing but 3 amperes and the direction is B to A. So now these two current sources are in parallel. You'll get one more equivalent current source by transforming these current sources or else by reducing these current sources. From A you have 3 amperes, the direction is B to A. You already reduced and got the equivalent values for this in the previous steps. So now 2 ampere is from A to B direction and 3 amperes is from B to A direction. It is nothing but these two currents are in opposite direction. So you'll get one equivalent current source and the direction of current is from obviously B to A because 3 ampere is having highest magnitude. The direction of that 3 ampere source is B to A. So that I will write it here B to A. That's nothing but current I is nothing but 3 difference 2, that is 3 minus 2, 1 ampere you are getting. And the value of resistors 1 ohm, see R equivalent 2. This 1 ohm is parallel to 3 ohm, that is nothing but 3 into 1 divided by 4, you can get 3 by 4. So 3 into 1 divided by 4, you can get 0.75, 0.75 ohm. This is R equivalent 2. And this is R equivalent 1, we already calculated. This is connected to B, A to B. So now these two current sources are in series. If these two current sources are in series, means you cannot add now. But at the end, what they asked you to get, what they asked you to find, or is what they asked you to reduce the network into a current source. So which means that you need to convert these two current sources into voltage source. You get one equivalent voltage source. Again, you need to convert that into current source. That's all. So now from A, I'm converting this current source into voltage source. We'll get 1 ohm resistor along with a voltage source. Again, 1 ohm, and the polarity is, see now the direction of current is B to A, that is nothing but minus plus. A side it is a plus, B side it is a minus, and V is given by I into R, and the value of I is 3, value of R is 1, so obviously it is 3 volts. Similarly, next we'll be having 0.75 ohm resistor is in series with the voltage source. By transforming this current source into voltage source, again the polarity can see B to A, minus and plus, it is nothing but plus minus. So we'll be having V equals to I into R. Again, I is 1, R is 0.75, you get 0.75 volts to the B. So now 3 voltage source and 0.75 voltage value will be having same polarity, so that the equivalent value of this voltage is by adding these two sources, and the polarity is same, that is nothing but V equals 3 plus 0.75 is nothing but 3.75 volts is in series with R equivalent 3, that is nothing but 1 plus 0.75, that is nothing but 1.75 ohm. But in the question what they asked, you need to reduce this network into current source, one current source. So that again you need to reduce this voltage source into current source. So at the end we'll get from A, you'll be having a resistor value that is nothing but 1.75 ohm, and the value of current plus to minus, that is nothing but arrow, minus to plus is nothing but B to A. Here we'll be having the value of current I. So this I is given by V divided by R, whereas V is 3.75 and R is 1.75. You can get 2.142. 2.142 ampere with respect to B. I equals to V by R. V is 3.75, R is 1.75. So this is the answer. Okay. So still if you want one more time, the explanation means you can see the network. You can do it everything in a one network also, but if you are doing step by step, you will not get any confusion again. So you want to get one equivalent current source, so that what you are doing, you are converting the all voltage sources into current sources, so that you can see the first step, converting this voltage source into current source. Again we get one equivalent current source, then two more voltage sources you are converting into current source. You'll get two current sources in series. You cannot add the current sources if they are connected in series, so that you're converting that into voltage source. So now we'll get two voltage sources which are in series, so that you can add the voltage sources. You can get at the end one final or else one equivalent voltage source, but they asked you to write in the form of current source, so that you need to convert this into current source. And this is about the problem. If you really like, or else if you really understand the problem, that's fine. If you're having any doubts regarding this problem, feel free to write in a comment box. And also, if you like this video, do a subscribe and share maximum. Thank you so much. Have a nice day.